All right, today we want to begin talking about properties of logarithms. In the last section, we talked a little bit about what logarithms were and how we solve those. Today, we want to be able to use some properties to make solving those a little easier for us. The first one we want to talk about is the product property. Product means that we're going to be multiplying. So if you look in our property here, we are multiplying u and v, and we have log base b of u times v. Using a property of logarithm, we are going to be able to now say that we can take that and break it into the log base b of u plus the log base b of v. The quotient property is division, the opposite of multiplication. So now we have log base b of u divided by b. So it's very similar to our product property, but instead of adding, we're now going to subtract. We're going to have log base b of u minus log base b of v. The last one that we're going to talk about is the power property, meaning that if we have log base b of some number to a power, u of n in this case, we can take that power out front and just take n, the power, times log base b of u. And you're probably asking yourself, yeah, that's great. I've got these properties now, but how are we going to use those? So let's take a look at some examples. We're going to use the fact that log base 5 of 3 is approximately 0.683, and log base 5 of 7 is approximately 1.209. And we want to be able to find, first, log base 5 of 3 divided by 7, or 3/7. What we want to be able to do is use that property. 3 divided by 7, that's division. If we flip back to our properties, we can see that we have division. We're going to subtract the log of base whatever we have of the numerator minus log base b of the denominator. So we're dealing with log base 5. So what we can do is we can say log base 5 of 3 minus log base 5 of 7. And we get 0.683, which is log base 5 of 3 given to us in the problem, minus 1.209, again given to us in the problem. We subtract those and we get negative 0.5 0.526. All right, so there's one. Now log base 5 of 21. Well, this doesn't seem like much, and it doesn't look like we have enough information given to us. But what we can do is we can take 21 and we can say that this is 3 times 7, and we can use our product property, and we're going to take log base 5 of 3 plus log base 5 of 7. Log base 5 of 3, again given to us in the problem, is 0.683. And log base 7 is 1.209. We add those together to get 1.892. And that is the answer we're looking for, as well as this negative 0.526 was the answer we were looking for in the last problem. Again, if we look at C, we're looking for log base 5 of 49. How can we make this fit either log base 5 of 7 or log base 5 of 3? Well, if we take a look, we can rewrite log base 5 of 49 as log base 5 of 7 squared. 49 is 7 squared, a property that you should know by now throughout your math career. Now, Our property tells us that when we have this power, we can bring it out front. So we can take 2 times log base 5 of 7, and from either the problem or our calculator, we're going to take 2 times 1.20. Would help if I wrote a 2. 1.209. Multiply those out, we get 2.418, and there's our answer. We're evaluating logarithms without our calculators, and we're able to get those knowing what log base 3 and log base 5, or log base 5 of 3 and log base 5 of 7 are. We're able to evaluate these 3 logarithms without much of a problem here. What we can also do is we can use these properties of logarithms to expand a problem. So if we have log base 2 of 7x cubed over y, assuming that x and y are positive, that'll make a difference. So if we just assume that we're working with positive numbers here, we're going to use our properties to just break this apart, see how we could get there. So the easiest one to identify right away is we've got a fraction, so we've got division going on. So we can take log base 2 of 7x cubed over y. And we know from our property that this is going to be log base 2 of 7x cubed minus log base 2 of y. And now, that looks like we've got a good start, but we also have multiplication going on between the 7 and the x cubed, which now that can be written as log base 2 of 7 plus log base 2 of x cubed minus log base 2 of y. So I just split that 7x cubed apart and added that into my expression that I'm expanding here. And the last thing that we notice is that I have a power here. So we'll use the last property and we'll go log base 2 of 7 plus 3 times log base 2 of x minus log base 2 of y. All we did on that last one was bring that exponent out front, just so we have log base 2 of something. Now we're going the other way with that. We're going to condense these into one expression. So the easiest thing we can do is take this 2 and move it back up here. It goes the other way. You can pull it down in front or bring it up top there. So you get log of 6. Since we don't see a 10, we're going to be under the assumption that these are all log base 10, which is what your calculator uses. We're going to add log of 2 squared minus log of 3. Simplify this, we get log 6 plus log of 4. 2 squared is 4. And subtract log of 3. Now, we've got addition here, which means that we can go ahead and multiply the 6 and the 4. And the subtraction means that we are going to divide. So our expression becomes 6 times 4, log of that, minus log of 3, or we can take log of 6 times 4 over 3. Simplify that out. That'll give you 8. and that is the answer that we're log of 8, not just 8. So you get log base 10 of 8. And that is how we can condense that down into one simple expression. The last thing we want to talk about today is the change of base formula. As I mentioned in the last slide, your calculator operates in base 10. Not everything is going to operate in base 10 for you. So we want to be able to still evaluate these with our calculators, even if we're using a different base that is not 10. So if we have log base c of u, what we can do is we can take log of whatever base we want of u divided by the same log of the same base of c. The way I keep this straight is when you read straight across, the u is higher up than the c is, so that's going to go in our numerator. The c is that subscript, so it's down below, so that has to go down below on our fraction in that denominator. So if we're going to use this with our calculators, we're going to take log base 10 of u divided by log base 10 of c, and you can also use what's called the natural log, ln of u divided by ln of c. It'll just depend on either what the problem asks for or what you're working with. That's going to be more beneficial to you in either case. Now, we want to evaluate the expression log base 3 of 7 using common and natural logs. So, common logs. This is going to be the log button on your calculator. Natural logs, that's that ln button that we were just talking about. So, if you're going to use log base 3 of 7, the 7 is higher up, it's bigger, it's going in the numerator. We're going to take log base 10 of 7 divided by log base 10 of 3. And if you plug log base 10 of 7 or hit log 7 on your calculator, you're going to get 0.8451 divided by hit log 3, you get 0.4771. That will give you, when you divide those out, 1.771. And that's what log base 3 of 7 is equal to, that 1.771. Now let's see if this happens to work if we use natural logarithms. So everything is blue is that common log. I'm going to work this out with natural logs now. So if I take ln of 7 divided by ln of 3, that natural log of 7, natural log of 3, you're going to get ln of 7 is going to be 1.946 divided by 1.099. And you're saying to yourself right now, 1.946 is nowhere close to 0.8451, and the same with 0.4771, 1.099. But let's divide them out, see what we get. When we divide those out on our calculator, you're going to get 1.771, which is the same answer. So that is what we want to see. All right, here's your homework. It's also posted on my website. We will check this on Monday. If you have any questions, feel free to stop by and let me know what's going on. If not, good luck. I will see you on Monday, and we will check this then.